Hey, good afternoon. Welcome to another episode of Biochemistry Unfolded from Atoms to Algorithms. And this is where I talk about a variety of interesting topics of interest to the biochemistry community. And so today I'm going to be talking about one of the oldest beverages produced in human civilization. And so that's for about the last, 10,000 years or so. That's going to be beer, right? But we're not going to be talking about the traditional beverage per se. We're going to be talking about non-alcoholic beers specifically. And these seem to have become more popular in recent years as many people are looking to cut back on their alcohol consumption for a variety of reasons. It could be health reasons, could be just they're trying to avoid legal repercussions, or maybe they just don't want to have the negative aspects of hangovers and that sort of thing. So it's become a lot more popular recently. But they still want to enjoy a cold frothy beverage, as well as maybe some hearty discussion at your local pub, right? Some of the current topics, and you still want to talk to people. It's kind of a social thing. So the first question we need to ask: what is non-alcoholic beer? Non-alcoholic beer is beer that contains very little alcohol. It's actually not truly non-alcoholic. It typically contains less than 0.5% alcohol by volume. Regular beer will have anywhere between 4 and 6% alcohol by volume, with high gravity beers getting up to about 7 to 10% alcohol by volume on average. And some, such as Brewmeister's Snake Venom, produced out of Scotland, checks in at a whopping 67.5% ABV. There's a debate over whether that's actually beer or not, of course, but yeah, technically it's marketed as beer. The goal for non-alcoholic beers is to make a beverage that tastes like beer but won't cause intoxication. In the United States, marketing non-alcoholic beer is regulated by two agencies: the Alcohol and Tobacco Tax and Trade Bureau, the TTB, as well as the Federal Food and Drug Administration, the FDA, depending on how the product is classified. Legally, in order to be classified as non-alcoholic, the beer must contain less than 0.5% ABV. Anything greater than 0.5% is legally considered to be alcoholic and therefore subject to the full regulation by the TTB. That also includes paying the appropriate alcohol taxes and adhering to distribution laws in the United States as well, including interstate distribution laws. So if it's less than 0.5% ABV, it must be labeled with the statement contains less than 0.5% alcohol by volume. The beverage cannot be labeled alcohol-free unless it contains 0.0% ABV. So you can say non-alcoholic if it's less than 0.5%, but you can't suggest it's suitable for children or safe for pregnant people to consume without proper disclaimers. Furthermore, if it's brewed like regular beer, but the alcohol is removed, it's still regulated in part by the federal TTB, such as for labeling as well as for advertising, even though it's not taxed like beer. Additionally, non-alcoholic beer advertising cannot make specific health claims or broad health claims, such as maybe it's good for hydration, it could be safe for diabetics, or it promotes relaxation, unless these claims are scientifically substantiated by peer-reviewed studies and approved by the FDA. So also nutritional labeling, such as calories, carbohydrates, etc., must also follow the FDA rules and guidelines for standard food products as well. These are not by the TTB, those are FDA guidelines for pretty much all food products, including all beverages, alcoholic or non-alcoholic as well. But it's not going to be taxed. Like non-alcoholic beers will not be taxed like alcohol. Now, some states may have stricter rules. For example, some states may not allow the sale of any beer, alcoholic or non-alcoholic, to minors. Those, and by this definition, we're considering minors under the age of 21. Some states might also require it to be sold in the alcohol section of a store, whether it's non-alcoholic or alcohol containing beer. So be sure to check your state-specific Alcohol Beverage Commission rules for your state's specific information. So how is non-alcoholic beer produced? Let's start this discussion with a brief review of how beer is normally produced, right? So the process is going to start with grains, such as barley or wheat. And these barley grains are soaked and germinated and then dried to develop specific enzymes. This process is known as malting. Following the malting process, we go to the mashing process, where the malt is mixed with hot water. And by hot water, we don't mean boiling, we mean a steeping temperature of approximately 160 to 170 degrees Fahrenheit to convert those starches into fermentable sugars, primarily maltose in this case. And so, again, it's very important to achieve the desired steeping temperature so that the enzymes, the alpha and beta amylase enzymes that are breaking down the starch, are at their optimum temperature, right? So temperature control is pretty much everything, whether you're brewing a regular beer or a non-alcoholic beer. You want to make sure the yeast and the enzymes are all at the optimum temperature. So once you go through the mashing process, you're going to then go to a boiling process, where you're going to start to boil that product. And so here's where you're going to bring that up to a boiling temperature. Boiling temperature of water is 212 degrees Fahrenheit, 100 degrees Celsius. And at this point, you're also going to add hops. And hops are added to the mixture, both to add bitterness and flavor, as well as the hops is added as a preservative. Since about 800 or 900 AD, hops has been added to beer in order to extend its lifetime so it can be shipped greater distances. And this is due to the isohumulone chemicals in the hops that, in addition to adding the bitterness and flavor, also have antibacterial properties and antiseptic properties, so they kind of keep, bad bacteria from growing in your beer. So that's really important. So once you boil, you usually boil for a micro beer, you're going to boil for about an hour or so. Now you've got wort. Wort is unfermented beer. This is simply a mixture of simple sugars, monosaccharides that are ready for fermentation. We also call these fermentable sugars. That wort needs to be cooled down. So the next process, of course, is cooling. And you need to cool this down because yeast is a microorganism. It's actually a fungus, Saccharomyces cerevisiae. That literally translates to sugar fungus of beer, going from the Latinized Greek definition of the words. And so you don't want to put yeast into a boiling temperature because you're probably going to kill the yeast, and that probably wouldn't do any good. You want the yeast to be alive so that it can actually undergo the process of fermentation following glycolysis, right? And so You're going to add your yeast once it's cooled to room temperature. The yeast is added to convert those sugars into alcohol, ethyl alcohol in this case, and carbon dioxide. And that process could take anywhere from 1 to 3 weeks, depending on your beer. It could take longer if you want to produce a higher gravity beer, for example. And once you produce, then the next step, of course, is conditioning and packaging and making it available for consumption. So you can either put that into a keg or bottling or cans or what have you. So when producing a non-alcoholic beer, they usually use two major processes. The first is by controlled fermentation. That is, you're preventing the alcohol from being produced by limiting the amount of fermentation that takes place in the vessels. So this process is stopped before too much alcohol is produced. And this can be done by using either a low sugar wort, which produces less fuel for the yeast, special yeast strains that produce less alcohol, or use lower temperatures to slow down the fermentation process. Now, the disadvantage of this process is that since you're doing less fermentation, you're also producing less of the flavorful aromatic compounds that add taste to the beer. These include esters such as isoamyl acetate or ethyl hexanoate. These esters give beer very fruity flavors. Overall, beer contains actually about 800 different chemicals that add, most of these add flavor in some way. And so if you reduce the fermentation, you're also reducing many of these flavor compounds. And so many non-alcoholic beers have traditionally been described as tasting potato-like or wort-like. And so we try and, the best process is try and minimize those negative tastes. The metabolism of yeast also greatly influences the taste and aroma profiles in beer. This can be influenced by a number of factors, including pH. In fact, the pH scale itself was developed in the early 20th century by Søren Sørensen, who worked at the Carlsberg Laboratory, that's associated with the Carlsberg Brewery, in Copenhagen, Denmark. And one of his primary interests, of course, was understanding how pH affected yeast growth and metabolism to brew a better beer. And so pH and the composition of the wort both have a major effect on the ester and alcohol production in beer. And traditionally, many non-alcoholic beers have developed these undesirable flavors due to incomplete fermentation. The other major process by which non-alcoholic beers are produced is dealcoholization. And that means pretty much what you think it means. It means that the alcohol is actually removed. You're brewing the beer as usual, and then you're removing the alcohol post-fermentation. But you're retaining most of the flavor ingredients. This mainly is based on the fact that ethyl alcohol has a lower boiling temperature than water. The boiling temperature from ethyl alcohol is about 78 degrees. The boiling temperature of water is 100 degrees. So if you reach a temperature of about 80 degrees, you'll boil off the alcohol, but you'll retain the water, which has a higher boiling temperature, right? So you can mainly, that's removing the alcohol by heating or evaporation, and you're still retaining most of the flavor compounds in that mixture. Now you can also remove the alcohol by vacuum distillation as well. And that's where you use lower pressure to reduce the boiling point of alcohol so that it can be removed at even lower temperatures. And that preserves the flavor a little bit better because it'll retain some of the compounds that might have a higher boiling point, right? A more advanced method would be membrane filtration, and this is where alcohol molecules are filtered out using specialized filters, using the process of osmosis. But this also requires very specialized equipment, and many of these equipment is fairly expensive, right? So dealcoholization processes are the most commonly used processes for commercial non-alcoholic beers that you would find in the grocery store. This is kind of this is because you've got a lot of specialized equipment, and in order to produce non-alcoholic beer at sufficient quantities required for sale, the expense of this equipment is usually only accessible to so-called macro brewers such as Anheuser-Busch, Miller, Coors, etc. Possibly some regional brewers might have some specialized investments that they've been able to acquire some of this technology as well. The smaller scale microbreweries that brew about 10,000 barrels per year or less typically don't have the budget for dealcoholization processes, and certainly home brewers, unless they work in a chemistry laboratory, they're probably not going to have access to all this equipment either. They might, but it just depends. College faculty teaching courses in fermentation and food science also, they very likely have these specialized equipment. Of course, you've got a full laboratory, and so you could certainly brew non-alcoholic beer for educational or research purposes. However, it's important to keep in mind if you're in this situation, you do need to remember that you are brewing, if it's dealcoholization, you're brewing beer with alcohol in it. And so you're subject to all the same regulations as brewing alcohol beer, right? And then you're removing the alcohol. So your university may have specific campus procedures that need to be followed, as well as state and local laws regarding fermentation. So you want to keep that in mind as well. Now, it's long been known that different strains of yeast ferment at different rates, right? I mean, we've been brewing for about 10,000 years. So, and if you ferment at different rates, you're going to produce different amounts of ethanol. Recent research into non-alcoholic beers or low-alcoholic beers, we kind of use the acronym NABLAB, N-A-B-L-A-B. A lot of recent research finds that some of these yeasts may also be able to produce very little alcohol. These include what's called maltose-negative yeasts. Now, what is maltose-negative yeast? First of all, maltose, this is also called maltobiose or malt sugar. This is one of the common carbohydrates that are produced from the grains that are used to produce beer. Maltose is a disaccharide consisting of two glucose molecules connected via a glycosidic linkage. And when beta amylase breaks down the starch found in barley, it produces maltose. This then enters the yeast cell for fermentation. And so maltose-negative yeast is yeast that does not ferment maltose. And so it will only ferment other simple sugars such as glucose, fructose, and sucrose. So it'll leave all that maltose there. It won't do anything with it and won't convert it to alcohol. And therefore, you'll typically produce less alcohol. There's a recent paper by Karoglan and colleagues. I apologize if I mispronounced the name. It's a Turkish. The paper is published in Turkey. It's at the Department of Food Technology, Science and Technology, the Science and Technology University in Sarıkam, Turkey. And so the paper is entitled Maltose-Negative Yeast in Non-Alcoholic and Low-Alcoholic Beer Production. And this is published in 2022 in the journal Fermentation. They found that the yeasts that many of these maltose-negative yeasts will enhance the flavor without the use of specialized equipment. And they also looked at many non-Saccharomyces yeasts, which produce very fruity aromas with minimal alcohol content as well. And so this is very important because yeast activity is critical for beer quality and sensory properties. The paper actually discusses several maltose-negative yeasts and explores their potential for their use in brewing. Many of these yeasts include Saccharomycodes, ludwigii, Brachia gallida, that's a psychrophile, extremely low temperature yeast, Pichia fermentans, Hansennia spora valbiensis, and then Zygosaccharomyces bailey and Zygosaccharomyces cambucaensis, as well as Brettanomyces bruxellensis. Furthermore, there's also some Ecuadorian strains of Saccharomyces cerevisiae, which show very low flocculation, low alcohol content, and higher ester production that could also be used in small quantities for non or low alcoholic beer production. Many of these strains are commercially available in smaller quantities so that home brewers may be interested in experimenting with brewing a non-alcoholic or low alcoholic content beer of their own. So if we kind of look at these, the paper has a lot more interesting. If I just look at a couple of these, first of all, I found Saccharomycodes ludwigii very interesting because this is a key yeast in non-alcoholic, low alcohol content beer production. And so it produces very low alcohol with retaining many of the fruity flavors. And studies actually show that varying alcohol levels and sensory characteristics are based on various fermentation conditions as well. So the yeast lack of maltase enzyme actually limits their ability to ferment maltose, and that affects the flavor. Another one is Pichia fermentans, and so this actually imparts a very unique spicy phenolic flavor to the beer that enhances its fruity flavors through glycosidase activity, and that's beneficial for many non-alcoholic beers. Hansennia spora valbiensis, this is isolated from grapes, and this contributes to many of the fruity flavors in the beer. And this can also be co-fermented with S. cerevisiae to enhance many of the aromatic properties as well. So you could actually use two different yeasts growing in the same fermenter at the same time. Two very common beer, yeasts are Zygosaccharomyces bailey and Zygosaccharomyces ruxi. And so these typically have a high tolerance to preservatives and produce very sweet, worty beers. And so it enhances the sweetness content, the taste. And you can have mixed fermentations that also yield very higher alcohol levels than single starters. So this could be a good beer to use if you're getting started as well. Zygosaccharomyces cambucaensis as well. This produces very sweet, worty beers with very high diacetyl levels. And so this has a limited maltose fermentation ability, but because of those diacetyl levels, it's still considered safe for use, but you might want to take that into account. And Brettanomyces bruxellensis, this is used in spontaneous fermentation, and that contributes to many of the unique flavors. It also has the ability to ferment complex carbohydrates that may lead to higher alcohol levels as well. So in addition to exploring the diverse varieties of the yeast used to produce maltose-negative products, the authors of the paper also looked at several other aspects of non-alcoholic, low-alcoholic content beers. This includes improved production techniques in the use of maltose-negative yeast that can significantly enhance the production of these beers. And these yeasts can be utilized without the need for specialized equipment, making the production process a lot more accessible and cost-effective, especially for microbrewers and homebrewers. So the research also indicated that employing maltose-negative yeast can also help eliminate many of the organoleptic taste issues commonly associated with non-alcoholic and low-alcoholic beers, such as the undesirable wort-like taste or the potato-like flavors. This is crucial for improving the overall sensory experience of these non-alcoholic beverages. They actually did some sensory evaluation studies, and it was found that beers produced with maltose-negative yeast had very distinct flavor profiles compared to traditional brewing methods. And this actually suggests that you have the potential for creating very unique and appealing flavors in non-alcoholic or low alcohol content beers that could be a new area, and not just reproducing the taste of a regular beer, but also you've got a new type of beer that it has its very own flavor profile, which is kind of cool in itself there. They also found that fermentation conditions such as temperature and yeast pitching rates also significantly affect the fermentation conditions. And they will therefore have an effect on the final product's flavor and alcohol content. So for example, beers fermented at lower temperatures tended to have immature and sweet flavors, while higher temperatures resulted in sour lactic flavors. So you could actually get more of a sour beer in this case here, if you're kind of a fan of sour beers. Right? The researchers also noted some specific yeast strains such as Saccharomycodes ludwigii and Saccharomyces ruxi, and these had varying abilities to ferment maltose to produce desirable flavors. This highlights the importance of selecting the right yeast strain for optimal non-alcoholic or low-alcoholic content beer production. Even more interesting, yeast can also be genetically modified to yield zero or reduced maltose fermentation using the CRISPR-Cas9 gene editing system. And CRISPR is a tool that targets specific sequences of DNA to cleave using the Cas9 protein, and then we can insert, or actually in this case, delete specific genes related to maltose transport in the yeast. And so the yeast focused on here is Saccharomyces eubianus, and what they did was delete the genes for SE-malt2 and SE-malt4 that are crucial for maltose uptake. The deletion of these genes resulted in the inability of the yeast strain CBS 12357T to grow on maltose, and that highlighted the role of those genes in maltose metabolism. They also did some overexpression studies to overexpress the SE-malt 1 to 4 genes in a maltose-negative S. cerevisiae strain. And so this manipulation showed it allowed the modified yeast to grow on maltose, demonstrating the potential of CRISPR-Cas9 to enhance yeast capabilities for fermentation processes as well. Another study done by Brickweddy and colleagues used CRISPR-Cas9 to study how parental genomes of cold-tolerant Saccharomyces eubianus contribute to maltose metabolism. And so this research aimed to clarify the genetic basis of maltose utilization in different yeast strains. And this is essential for optimizing many of these brewing processes for non-alcoholic and low alcohol content beers. the study also found that there's simultaneous expression of both maltase and maltose transporter that's necessary for the growth of maltose-negative yeast strains on maltose. And so this insight was facilitated by CRISPR-Cas9, and that allowed researchers to manipulate the gene expression levels very effectively. So the CRISPR-Cas9 technique can also be used to target and cut out very specific malloci and other related genes. So some of these also include MPH2 and MPH3. These encode alpha-glucoside hydrolase. This targeted approach was aimed at abolishing the alpha-glucosides, and so that further demonstrates the use of CRISPR-Cas9 in yeast genetic engineering. So that's also helps to lower the amount of fermentable sugars that are available, so that you produce less alcohol overall. So overall, CRISPR-Cas9 is a very powerful tool that can be used in the study and modification of yeast strains. And so this helps us in understanding and enhancing maltose metabolism. This is critical for the production of non-alcoholic and low alcoholic content beers. Overall, there's a lot of research that has gone into non-alcohol, low alcohol content beers recently. I can remember back in the 1980s discovering my first non-alcoholic beer growing up, and I was kind of about 10 years old at the time, and I think I was able to taste it back then, and I was like, that tastes like crap. That was no good. Yet the more we learn about these processes, clearly a lot of, since the 1980s, we've done a lot of research, and the more we learn about the processes and techniques, specifically in the use of maltose-negative yeast in the production of non-alcoholic beers, to effectively eliminate many of the taste issues, undesirable flavors, etc., and then introduce new appealing flavors without the need of specialized brewing equipment, the more common these beers are going to become available to more consumers. But we do need ongoing research into maltose-negative yeast, and that's going to be critical moving forward. It's expected to yield very diverse and successful results in non-alcoholic beer production. And so the exploration of many of these yeast varieties will likely lead to improved characteristics and flavors in these beverages, and maybe even some newly developed beverages as well. And this is promising because there's a very growing interest and potential in the area of non-alcoholic beers in the United States and globally as well. So certainly the brewing industry should continue to investigate and utilize maltose-negative yeasts as they offer a sustainable and innovative approach to producing flavorful and good-tasting non-alcoholic beers. This also aligns with the increasing consumer demand for healthier beverage options as well. And so the authors of this study also emphasize the need for further research into the aromatic potential as well as the safety of various maltose-negative yeast strains. And so this will also significantly enhance the production of non-alcoholic and low alcoholic content beers and cater to evolving market demands. So I hope you've enjoyed this analysis and this discussion of non-alcoholic beers. And go ahead and like and subscribe to the channel if you find this content very interesting and want to learn more. If you're very interested in this topic and you have other things to suggest, or if there's other things that you want discussed about that, maybe you have questions, go ahead and put a comment down in the comments below. I'd be very interested in reading your comments. So for now, thank you for watching, and I will see you again. And thank you.